So, the surface area of a sphere is given by the following formula. A equals 4 pi r squared. And its volume is 4 over 3 r cubed. Where r is the radius of the sphere. Show that if we have two spheres of radii r1 and r2 respectively, then the ratio of the surface areas can be written as a1 over a2 equals phi1 over phi2 to the power of 2 over 3. Alright, there's something that you need to, when I have a question like this, and it seems so random and the letters just seem to be in the most oddest arrangement possible, what I do is I make a list of how many letters I have at the start. So what I'd say is I technically have a1 equals 4 pi r1 squared. Are we cool with that? I would have a2 is 4 pi r2 squared. I then have b1 which is 4 over 3 pi r1 cubed. And then I have b2 which is 4 over 3, what is it? Pi r2 cubed. Alright. Which letters are not in the answer? Which letters don't exist in the answer? Yeah. We can only assume the pi's cancel each other out, can't we? That's what usually happens. And what answers are we missing? R1 and R2 go missing, don't they? Would you agree with that? R1 and R2 go missing. Here's my suggestion, okay? My suggestion is, what variable links A1 to V1? What variable do they have in common? Pi is not a variable, by the way. Pi is just like the number 5. You have R1 in common. Everybody agree with that? We're going to link the two of them using R1s. Okay, what about A2 and V2? What do they have in common? R2. So we're going to use R2 to link the two variables together, okay? So here's my suggestion. My suggestion would be A2, which is A2, which is 4 pi over R2 squared, yeah? We're going to get R2 on its own. So how do we get R2 on its own? A2 divided by, anybody? 4 pi equals R2 squared. And then finally, what's R2 on its own then? Whatever we say the square root of A2 over 4 pi. Is that right? What would R1 be using the exact same technique? R1 would be A1 over 4 pi. Because it's the exact same equation. Would that make sense? Now, I now have A2 over 4 pi to the power of a half. Does that make sense? And then I have A1 to the power of 4 pi to the power of a half equals R2. Alright, anybody have any ideas what I'm going to do with these two equations? Anybody have any idea? Huh? Let me see. Yeah, we're going to substitute in for A on both of them. And then we can isolate A1 and A2. Isolate A1 and A2 and then put them over each other. That would make sense, okay? So what we want is we want A1 equals something 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 phi1. Then we want A2 equals something 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 phi2. You get what I'm saying? And then at the very end we can just divide the answer for A1 by the answer of A2. Does that make sense? You're going to divide the answer for A1 divided by the answer of A2. Okay? So we're going to have two separate answers. We have to introduce phi into the equation somehow. So what's our first thing we're going to do? What are we going to do with V1 as an example? V1 is 4 over 3 pi. And what am I going to do with R1? What's going in there instead? What's going in? A1 over 4 pi. Is that okay? And what's going in for phi 2? 4 over 3 pi. And over here, a2 over 4 pi cubed. We all good so far? Now, oh, I forgot to the power of. I forgot the power of a half as well, so I'm just going to slot that in here. Now, what's a half to the power of 3? What's a half to the power of 3, lads? Huh? Everybody happy with 3 over 2? So everybody happy that phi 1 is 4 over 3 pi. 4 over 3 1 pi. A1 to the power of 3 over 2. And 4 pi to the power of 3 over 2. What's phi 2? Yeah, hurry up. What's phi 2, lads? 4 over 3 pi. A2 to the power of 3 over 2. And 4 pi to the power of 3 over 2. Now, if I reread the original question, what does the original question want from me? It wants A1 on its own and A2 on its own. So I want to get A1 and A2 on its own. So I go back down here again. Now, my goal of the question is I want this part on its own and I want this part on its own. So I'm going to start moving everything around. The good news is, do I have to do them both or do I just need to do one of them and then just replace the letters accordingly? Just need to do one of them, don't I? Because they're exactly the same thing. Alright, so I just need to do one of them. So I'm going to do A1. Alright, and here's what we're going to get. We're going to bring up the 3 and bring down the 4. So what do we get? 3b1 divided by 4 pi. Everybody cool with that? What am I going to do with this 4 pi 3 over 2? It's division on the right, which will make it multiplication on the left. And you're going to see everything's just going to cancel very soon. Everything's just going to chop off and you're going to be grand with this, right? So this is 4 pi 3 over 2. Everybody cool with that? What do I have left on its own here? I have A1 to the power of 3 over 2. Here's the difficult part for you. Alright? This is the very difficult part, and I'm going to make it really easy on this, alright? If I have x squared equals 25, you guys would usually just tell me, sir, the answer is 5. No bother, yeah? Do you know what actually happens? Here's what actually happens. Would everybody agree that's x to the power 2 over 1? And what happens when I throw the power over the other side? What happens to the power? The power actually turns upside down. So what is 25 to the power of a half? 5. It means square root, doesn't it? Can anybody therefore tell me what would happen to the 3 over 2 when I just fling it over the other side? It's all going to become 2 over 3. Does that make sense? Alright. So, all of this on its own. I know, lads, this one is tough. Like, I had me thinking for a minute, so like I feel like it's a tough one. Let's keep going. Guys, so once again, a much less complicated way of, we're going to reduce this down to a more simple fraction, okay? What would happen if I had 3 over 4 to the power 2/3? What would you have done in the past? It's 3 to the power 2/3 divided by 4 to the power 2/3. Does that make sense? The 2/3 acts on every individual part. Does that make sense? Can anybody therefore predict what did the 2/3 do to this? Yeah, I would say I'm going to break it up into each individual part. 3 to the power 2/3. phi1 to the power 2/3. 4 pi to the power 2/3. I know. What's 3 over 2 by 2 over 3? 3 over 2 multiplied by 2 over 3? Just cancels into 1. And finally you have A1. Thank God. Now, what's the great thing about this then? What's A2 going to be? A2 is going to be exactly the same thing except what? Anywhere where there's a 1, there's going to be a 2. Now, long and behold, what's going to happen to every single variable? Gone, 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 gone. And what do we have left? And about time we got this. We have phi1 to the power 2/3 divided by phi2 to the power 2/3. Now, in the same way, if I have 2 to the power 4 divided by 3 to the power 4, what way can I present that? I can present it as 2/3 to the power of 4. Using the example I just showed you, what can you tell me about this? How would you finish it off? Yeah, so phi1 over phi2 to the power of 2/3. Now, let's have a look at this one. If two spheres have volumes 162 and 384 respectively, find the ratio of their areas expressed in the answers in B over 3. A over B. B over 3. Over B. Well, to me that would be 4 over 3 pi r cubed. This is a junior cert question, if anything. Are you trying to use the answer from part 1?
No, I mean like for B1, if you want to get back out.
Yeah, I don't. But yeah, did it work out for you?
Yeah.
Happy days. Take a photo of it and put it up online later. I'm serious. Why not? Alright guys, this one here, I think we're just using the formula from the previous question. A1 over A2 equals phi1 over phi2 to the power of, well, it's 2 over 3, is it? Are we okay with that? Now, 384 divided by 162 to the power of 2 over 3. Well, that's pretty handy actually. Just throw all that into the calculator and what do we get? Doesn't have as bad as we thought it was. That's 64 over 27. And then we shift, there's a button here, see this button here? You go shift that button there, and you do 2/3. And what's the answer? The answer of the last part, what that was. Yep. Oh dear, that's not a fraction form. Nope. Alright, so if something like that backfires on you, okay, which it just did, what was the answer I got a second ago when I put this into calculator? 64 over 27, yeah? And what I was attempting to do was put 64 over 27 to the power of 2 over 3. It should come out as a fraction, but if it doesn't, you may have to do each part individually, which can be an issue at times. Let's try again. Oh, can't work that time for some reason. Fair enough. 16 over 9. Good. And I want me to do 14. Yeah. Alright. 14. So, f blank equals 3 blank take away 1. I'm going to need 2 of these, haven't I? Alright. Conal, what's n minus 1 then?
Alright.
Sorry, what's n plus 3? Where do I put the n plus 3? There and there. Next step, how do I break this up? 3 to the power of n and 3 to the power of 3 is not 9, but it's 27, but yeah. Now, 3 to the power of 3 is 27, so it's 27 3 to the power of n's take away 1. Alright. How about the next one, lads? We're doing, actually we just need n, that's no big deal. It's a handy one. Now, take the two of them away from each other. Or sorry, add the two of them together. So it's going to be 27 3 to the power of n take away 1 plus 3 to the power of n take away 1. Alright, How many 3 to the power of n's is there going to be? How many 3 to the power of n's is there? 27 of them plus one of them is 28 of them, we're hoping. Take away 2. Everybody cool with that? Everybody happy with 28 3 to the power of n's, take away 2. Now, that's that part done. The part I have in the box is complete. Now we got to look at KFN. Oh, lads. No. Back we go. The -1 is in the power, not in the bottom. Excuse me. I royally messed up there. I wrote as this. 3n minus 1. I wrote as 3 to the power of n, take away 1. See the massive, massive, massive difference? Please tell me if I do something like that earlier. Okay, so I don't have to go back all over it again. Now, let's try this again. 3 to the power of n. 3 to the power of 3. But you know what? That really mucked me up there at the start. That's the way I presented it. 3 to the power of minus 1. Everybody cool with that? Would everybody agree it's 3 to the power of 2, 3 to the power of n? Which is how many of them? I added the 3 and the -1 together. Would everybody agree that's 9 of them? Right? Now what's Fn on its own? Fn on its own is 3 to the power of n, 3 to the power of -1. It's going to be interesting. Alright. And what do we get for that then? What's 3 to the power of -1? Yeah. It's 1/3 3 to the power of n. In a way, it's like 9x and 1/3 x. Do you get what I'm saying? It's like 9x and 1/3 x, yes? Huh?
3 to the power of n.
3 to the power of n minus 1. Yeah?
Yeah,
So 3 to the power of n, but 3 to the power of -1.
yeah, but doesn't want to find like number.
Yeah, there's a number in front of that. Yeah, I haven't got there yet.
Oh,
I'm working on it. Alright. Alright, guys. Now, Mr. McDonald's right. What we have to do next is we do 3 to the power of 3n. Alright. Then we add our answer for Fn, which is 1/3 3 to the power of n. And it equals k times Fn. And Fn is what we have here. It's k times 1/3 3 to the power of n. Is that okay with you guys? Now, very simply, it's the same question as 9x plus 1/3 x equals k times 1/3 x. This question in red is essentially the same question that we're doing in blue. They're the same thing. All we got to do is find out what the k value is to make it work. Okay. What's 9 plus 1/3? It's going to be 28/3 when you do it in the calculator, okay? And then, what's k times 1/3? Is k/3, 3 to the power of n. Therefore, k equals 28. Is that the answer in the back? Okay.